Hey guys, what's up? I hope everyone is fine and safe. And we'll be moving further to few of the problems which are left over. I think we'll be completing all the leftover problems today itself, and our whole trigonometry chapter is over. This is the last part that we are doing, that is trigonometric identities. Yesterday, in the previous video, we have already seen what are the identities which are actually applicable to our syllabus. There are so many, there are many trigonometric identities, but then these are the basic one which is applicable for us now. That is nothing but sine square plus cos square theta is equals to 1. Right here, and it's a plus, and it is establishing a relationship between sine and cos. The second one is secant square theta minus tan square theta is equals to 1. Here it is plus, but here it is minus. To remember this. Okay, so it is establishing relationship between secant theta and tan theta. Right now, the third one is cosecant square theta minus cot square theta is 1. So these three identities we need to mark. Okay, now like yesterday we have done till the second problem of exercise 11.4. Now we'll be moving further with 11.4 exercise third problem. It's given that show that root of 1 plus sine a by 1 minus sine a is equal to secant a plus tan a. Whenever we have a problem in such things, like we have to show that or prove that, what we will be doing, taking the left hand side, taking this value as left hand side and taking this value as right hand side. We are starting with the left hand side and will end up and show that it is equal to the right hand side, right? So first let us write LHS. What is LHS? Root of 1 plus sine a divided by 1 minus sine a. Okay, herein if you even you try harder to even solve the next step, okay, you will not get it unless and until you multiply or divide or do some additions to this value. So here we are rationalizing. Bring the value. See what is there in the numerator? 1 minus sine a. Okay, if we need to rationalize, what we do, we convert this minus to plus. 1 plus sine a. Okay, so what is rationalizing? It is nothing but multiplying and dividing by 1 plus sine a. Okay, since we want to take the opposite sign of it, of the denominator, we did it. Okay, now let us solve further. We will take all these things under the root itself. 1 plus sine a divided by 1 minus sine a. This is already given. Okay, what we are additionally multiplying and dividing with this value. 1 plus sine a divided by 1 plus sine a. The thing will be same, obviously same, multiply and divide by the same number, same sign and everything same. Okay, so now what is it? 1 plus sine a into 1 plus sine a. It is nothing but root of 1 plus sine a the whole square, right? 1 plus sine a into 1 plus sine a is nothing but 1 plus sine a the whole square, right? Then you check out that number in the the thing in the denominator. It is 1 minus sine a into 1 plus sine a. So by seeing this, what is getting clicked into your mind? Which identity? It is a plus b into a minus b is equals to a square minus b square, right? So herein a is nothing but 1 and b is nothing but sine a, right? So using this formula, we are converting it into 1 square minus sine square a. Sine a square will not write, will always give the square to the the identity, the ratio. Okay, so 1 plus sine a the square divided by 1 square minus sine a square. We got this using this identity of a plus b into a minus b equal to a square minus b square. Right, now let us see okay, now what we are going to do, we will be if we have to use trigonometric identity, the best thing that what we can do is replace this sine square value, sine square theta value, right? So we know that sine square theta plus cos square theta is equals to 1, right? So we want the value of sine square theta. So what it will be? Sine square theta will be equal to 1. This cos we are sending the other side of the equation. 1 minus cos square theta, right? So what we are doing here, we are replacing the sine square a value with 1 minus cos square a. So which is equals to root of, so we are writing same as it is, 1 plus sine a the whole square. Okay, now we are dividing by 1 square is 1 minus sine square a. In place of sine square a, what should we take? Which identity we should take? It is 1 minus cos square theta, I mean a. Since it's a, we'll take a, not theta, which is equals to root of 1 plus sine a whole square divided by 1 minus 1 minus into, see, 1 is 1, minus into plus we are taking minus 1, minus into minus, it is plus cos square a, right? So here in plus 1 and minus 1 get 0. Okay, so it is equal to 1 plus sine a the whole square divided by what are we left with? Cos square a, right? Now herein what we can do, we can easily remove the square and a root. See, if we see here, we will divide the square between the numerator and denominator for our ease. 1 plus sine a the whole square divided by cos square a. Okay, we are just dividing the root. So this root and this square gets cancelled. This root and this square gets cancelled. So answer is 1 plus sine a divided by cos a. We are left with it. But what in what terms it is given in our solution? It is secant and tan terms. So what are we doing? What are we doing here? We are simply splitting up the values. I mean splitting up the denominator. Okay. So 1 plus sine a divided by cos a can also be written as 1 by cos a plus, okay, sine a by cos a. Okay, seeing this values, what is clicking to your mind? What is 1 by cos a? It is secant theta, secant a. Okay, what is sine a by cos a? It is nothing but into, I mean plus, sorry, it's a plus, be careful with the sign, it's a plus. Sine a by cos a, it is tan a. Okay, did we get the answer? Is this the RHS? Yes, it is the RHS, hence proved. Okay, we got the exact answer. Secant a plus tan a, we got the answer as secant a plus tan a. Now we'll quickly move on to the fourth problem, that is show that 1 minus tan square a divided by cot square a minus 1 equal to tan square a. We need to show. So again, it's a matter of LHS and an RHS. Okay, whenever you are given with tan and cot, you should be feeling happy that you can directly substitute the sine and cos formula. Okay, and then proceed further for your calculations. That will be the most easiest one. Directly you will get the tan square answer. Let's start with it. LHS is equals to 1 minus tan square a. We're just copying the question. Okay, cot square a minus 1, right? Now what are we doing? We are substituting the values of tan and cot. What is the formula for tan theta? It is sine theta divided by cos theta, right? And what is the cot theta? It is the inverse of tan. That is nothing but cos square theta divided by sine theta. Okay, sorry, cos theta divided by sine theta. Okay, now LH is given as 1 minus tan square a by cot square a minus 1. So what are we doing? Instead of tan, what are we taking? We are taking sine and cos. So 1 minus, since it's not just tan, it's a square, we'll take 1 minus sine square a divided by cos square a, right? This is just the value of tan. Now we are dividing whole divided by cot square. Instead of cot, what are we taking? Cos by sine. So cos a since it's a square, we are taking square, copying square as it is, divided by sine square a minus 1. Okay, we have done nothing in this thing except for replacing the tan and cot value with the formula. Okay, now we just need to simplify it. Very simple, right? So what are we doing here? We are just taking out the LCM. Okay, so we do have 1 in the denominator, so LCM will be we have to multiply and divide it by cos square a. So cos square a minus sine square a divided by cos square a. It's just the numerator that we got. We just got the numerator. Now we are left with the denominator also. So here and also there's we need to take out the LCM, sine square a and 1. What is the LCM of it? Sine square a, right? So we will be multiplying and dividing by the same sine square a here. Okay, it's just the simple LCM. Okay, we are writing this cos square a as it is, and here in minus sine square a, right? Do we get here? What we can next step is that since it's like so many numerators and so many denominators, the best thing what we always do in our problems is make simplifying it, in the normal form. First we'll copy this, the first part of it, the whole big numerator, minus sine square a divided by cos square a. Right, now what are we doing? We are getting this denominator to the numerator, so it get inversed. It's nothing but if it's getting above, it's sine square a divided by, it get inversed when we get in multiplication, cos square a minus sine square a, right? We are just inversing this thing. We are doing nothing. Now seeing this, what we can say, sine square a minus cos square a minus sine square a and cos square a minus sine square a. It's in the division form, right? Multiplication and division form, so they get cancelled. What are we left with? We are left with, from here we see, if we see, we are left with 1 into sine square a. So sine square a, and we are left with cos square a. So what is the formula for sine divided by cos? It's nothing but tan, right? Since it's a square, both the things, we are taking square a. Isn't it RHS? Yes, it is RHS. We got our answer. Now fifth problem is saying that show that 1 by cos theta minus of cos theta is nothing but tan theta into sin theta. Let us take this LHS and this is RHS. Let's start a problem. LHS, copy the LHS, the question. 1 divided by cos theta minus cos theta. Okay, in this problem, that's nothing but LCM is cos theta. Here in 1 is 1. And since it doesn't have anything in the denominator, its numerator should be divided, multiplied by cos theta. Okay, the basic LCM that we usually do. So the cos theta into cos theta is nothing but cos square theta, right? So seeing this, anytime when you get a square term, you should first go and check the identity. Do we have any identity pertaining to cos square and sine square? Yes, we do have. What is that? We should just learn one thing, and directly you will get in your answer, directly you can find out another value. Okay, sine square theta plus cos square theta is 1. This is what the identity we know. But what all is given here? It's cos square theta, right? So what we'll be doing, we will be changing this cos square theta value. So we will be finding out cos square theta value here in the identity is equals to 1 minus sine square theta, right? So what are we doing here? We'll just replace cos square theta value as 1 minus sine square theta. 1 for 1 as it is, we are taking 1, minus ka minus, and instead of cos square theta we are using it as 1 minus sine square theta, right, divided by cos theta. Okay, now Just open the brackets. 1 we are writing minus into plus. 1 is nothing but minus 1. Minus into minus, it is plus. Okay, sine square theta. Did you get that? It just, we are opening the bracket, divided by cos theta. Here in plus 1 and minus 1 gets cancelled. What are we left with? Sine square theta divided by cos theta. Okay, now what we will do from this step, we will be taking our RHS. Okay, we'll be taking our RHS. Okay, what are we doing here? RHS is equals to tan theta into sine theta. We'll try to simplify this. What is tan? What is tan? It is sine theta divided by cos theta into sine theta, right? So at the end, what it is? Sine theta into sine theta. It's not a plus so that we can take LCM. It is into. It is a multiplication. So directly we can, multiply the numerator. Sine theta into sine theta, sine square theta divided by cos theta. Since it's an LCM, so cos into 1 is cos theta. So are these values same? Yes. So LHS is equals to RHS. Hence proved. Let us move on to the sixth problem. Simplify secant A into 1 minus sine A into secant A plus tan A. Herein there is nothing to prove. We need to simplify, get the simplified form of it. Okay, now what are we doing? First, let us copy the given aspect. Always secant A into 1 minus sine A into secant A plus tan A. Okay. Now, what are we doing here? Everything is in multiplication. So, what are we doing? We'll be multiplying. First, we'll multiply secant with the first term. Okay. So, secant into 1, secant A into 1, it is secant A. Okay. Minus come minus. Secant A into sine A is nothing but secant A into sine A. Right? We got this. Next, it is into secant A plus tan A. Okay, we got this. Now, seeing this, we have secant minus secant A into sine A into secant A plus tan A. Most of the terms are in secant and tan. Okay, so what we will try to do here, you can see that there's some relationship between here. What is secant A? It's nothing but 1 by cos A. Right? So, what we will do here, we'll try to convert the secant into cos and then get the tan value. What is tan A? It's nothing but sine A divided by cos A, right? This is the formula. So what are we doing? We're writing secant A as it is here. Okay, the only thing we'll be changing here is this secant A, because it's attached to a sine. What we will do to get in one term, sine and cos term, what we will do, what is secant? 1 by cos A. So 1 divided by cos A. We are writing this. Okay, and sine as it is into sine A as it is. Okay, we are ending up here, and this one as it is, we are copying secant A plus tan A. Okay, now secant A as usual, and herein it's nothing but sine A divided by cos A. Okay, 1 into sine A is nothing but sine A divided by cos A into secant A plus tan A. Now secant A is equal to, what is sine A divided by cos A? It is tan A. Sorry, secant A minus, this is nothing but tan A. This formula we are using here, we are changing only this thing. Okay, into secant A plus tan A. Seeing this, aren't you getting an idea of an identity that is nothing but A minus B into A plus B, which is equals to A square minus B square? Yes. So this is A, this is B. Okay, A and B, same things, right? So it is nothing but secant square A minus tan square A, right? See, plus and plus, plus and minus, and A square minus B square. A square, this is nothing but A square minus B square, right? Simple. Now, do we have any identity relating to tan and secant? Yes, we do have. That is nothing but secant square theta minus tan square theta is nothing but 1, right? So directly answer is 1. So this is the simplified form. Remember, from exam point of view, these problems are really important for 4 marks, these kind of problems. So be prepared with these problems and have a clarity of these problems. It will be very helpful for your exams, and it is sure to come in your exams. So we will be doing in our next video, we'll be doing all the other leftover problems, and we'll be ending up the trigonometry chapter. And if you really like my video, my way of teaching, do like and subscribe my channel and share with your friends. So till then, have a nice day, take care, bye bye.